2021 will bring lots of success and happiness to you and your family.
Thank you, sir. Sir, Happy New Year to you as well and to your family as well.
Thank you. Thank you.
Thank you, sir. Happy New Year, sir.
Thank you. Okay, let's start the class. And one or two students have requested me from section 2. They have missed the morning class, so they like to do the class with section 1. Is there anyone from that section? Okay, maybe they will join. Okay, so today actually I will finish the lecture. Before starting the lecture, let's have the next week plan. And okay, I'm planning. I have talked with Akib. I think you are here. What I am planning, I have talked with Fayad. So please talk with him and make it confirm. The thing is that we have only 1 week, and I have two days. Actually, we have Tuesday. Just Tuesday. So on that day, both sections, I like to take an that is the quiz number 3 on last week lab on lecture 12 and 13, and quiz number 4 will be an assignment. This is the plan about the theory class. Okay, so I have two options for you regarding the lab: Thursday or Friday, as per your convenience. Okay, let's have the plan first. Okay, for the lab, I will take a 30-minute quiz, online lab quiz. Okay, so the question will be true, false, MCQ, and short answer means 3 or 4 word answer. Okay, it will be online, and as per our lab, the lab we have conducted, based on that, we will have a 30-minute online lab quiz. Okay, it will take 30 minutes. So either both the sections can agree. If you agree, then we can take on Thursday afternoon and or Friday anytime. And actually, I will just put the question online and you will give it in Google form. That's it. Maybe I will schedule it and you will submit it in a stipulated time, in a predefined time. This is about the lab quiz. And one final lab task. I'm assigning the task, but randomly I will assign 3 tasks, and I will give some time for 2 or 3 days. Maybe on next Thursday I will assign it, and I will give 2 or 3 days. Okay. Randomly I will put 3 tasks. One is using LED, using say 8 LED, using 8 LEDs. You have to develop one say elevator control system. Elevator control. Likewise, say using port A of 8255, if you can connect 8 LEDs, you may need to program that the lift will stop over only at the odd levels or at the even levels. So this is how one task might be assigned. The second, 2 or 3-digit counter using 7-segment display. This is the second task. For this is another choice, and the third one is I may assign one task that already I have told you that if it is possible, make some scrolling few texts in our LCD using LCD scrolling few text using LCD. And we have seen the LEDs, we have seen the 7-segment display interfacing, and we have seen the LED interfacing. So I'm planning to give you this final lab task, and I may give it to you on Thursday, or you may take how much time you need. You may tell me, and then you can work on it. Or I can assign the task on this Sunday, or you may take 7 days, no problem. So which one you prefer, you just let me know. But surely the final lab quiz will be on either Thursday or Friday. And on Tuesday, I like to take at any time, both section can sit. And this is also for, let's say, 25 minutes, including upload time, 5 minutes. And quiz 4 will be an assignment, or later on I will decide. Regarding this, I have some doubt. Maybe I can make some average of the earlier 3, or if you say no, I have missed few of the quiz. So if anyone like to have the assignment, I will put that. Is it okay?
Yes, sir.
Is it clear, Akib and others? Any query about the next week plan?
Sir, then I think I will talk with Fayad, and we'll inform you a suitable time for the quiz for both the sections.
Yes. So I need, in fact, in real time, I need two schedule from your side. One is for the quiz number 3, and one is the lab quiz.
Yes,
and rest of the things we may just assign you, and you will just submit it. You will do by yourself.
Okay, sir.
So that's it. And I'll not take any Viva or anything else. Just 2 things I like to take. Okay, so please let me know by today if it is possible, because if you like to take the assignment earlier, final lab task, then I may assign it on next Sunday.
Okay, sir. Inshallah, we'll try our best to let you know within today.
Okay, thank you. Okay, so let's start today's class. Before that, I'll just make a review of the earlier day's class. And this lecture was finished, and where I have discussed about the 8251 serial input-output USART, Universal Synchronous Asynchronous Receive Transmit Controller. This is an internal integrated circuit or interface, and based on that, the EIA 232 or serial interface was developed. We have discussed that. Apart from this, we have discussed about USB, then firewire, SCSI, InfiniBand, and fiber channel for internet communication. And also we have seen USB, firewire, DVI, HDMI, the concept of isochronous, SCSI, InfiniBand, fiber channel, and the wireless interfaces, and the revolution towards wireless interfaces we have seen based on the infrared signal and based on the radio frequency signal. And I've talked about some wireless protocols on infrared, on Bluetooth, and what speed we have achieved, we have shown you, and the wireless protocol related to Wi-Fi, because Wi-Fi nowadays we are in a transition phase for IoT, specifically for IoT. Just from here, I will start talking today's class, and then I will start a protocol of IoT. First of all, that we have Bluetooth as one interface, Bluetooth interface for exchanging the IO signals. For exchanging IO signals, we are using Bluetooth, and in Bluetooth, we are using the radio frequency, the RF radio frequency. And you know that radio frequency are of two types. One is radio wave, another is microwave. Okay. And Bluetooth, after Bluetooth, we are having Wi-Fi based on the wireless LAN technology. And both of these, Bluetooth has a one standard, Wi-Fi has a one standard. Both of these uses the radio frequency. Now, the spectrum range for radio frequency lies in between 300 kilohertz up to 300 gigahertz. The frequencies are mapped within that. Beyond this radio signals, we have the infrared signal, we have the X-ray signal, we have the gamma, cosmic ray, gamma ray. Those are hazardous signals. But for radio frequency, we use these frequencies for exchanging our data. Now, why I have introduced this spectrum in between 300 kilohertz up to 300 gigahertz. These range actually regulated by some authorized body. In Bangladesh, in every country, there are some authorized body who takes care of this frequency. Actually, this frequency is God gifted. We can't see that, but in the air, this radio frequency, by using this radio frequency, we exchange the data. But there is some regulatory commission in every country. In Bangladesh, you may heard the name of BTRC, Bangladesh Telecommunication Regulatory Commission, who actually sells the frequencies to the service providers, to the network providers. But okay, BTRC sells frequencies to whom? BTRC sells frequencies to the mobile operators, to the FM radio transmitters. They sell radar for radar communication. If any organization make radar communication, satellite communication. So for different organizations, BTRC sells the or ensures the licensed occupation of the radio frequencies. Now, there is one frequency that is called this range in between 2.4 to 2.48 gigahertz, and as well as another frequency is 5 gigahertz range. This particular frequency lies in between here. Okay, in between 300 kilohertz up to 300 gigahertz. For this frequency, we say this is an unlicensed band. We say this is an unlicensed band. Unlicensed means BTRC doesn't provide any license for this. So taking these as an advantage, and this unlicensed band is, in short, we say this is called ISM band. ISM stands for industry, science, and medical. Okay. Now, why ISM band is free? Because particularly for industry, for science, and for the medical purpose, we have the R&D section, research and development section. And for the research and development section, it's kind of, you can say that it's kind of an incentives for the research and development sector. So you use the ISM band and you don't need to pay any money or any fee to the government. So that is why ISM band is free and unlicensed. But the problem is, okay, from that objective, ISM band was introduced. But nowadays, what we are doing through wireless LAN, you see, first wireless LAN was developed in a way that we have an AP access point, and with that we have the antenna, and within its range, the devices, those are connected. Let's say we have the laptops, we have the PCs. Okay. So the devices which are connected with the access point wirelessly, we say this is the wireless LAN. No problem, fine. For this purpose, actually, we use the unlicensed band. And this is called wireless LAN. But the problem has created when in the backhaul network, we have connected this access point with whom? With the internet. The problem has become very challenging because these devices, now we are using these devices for huge amount of traffic. We are exchanging by using these devices to and from the internet. Now you see the goal was to give the unlicensing band for the research and development sector, but nowadays we are using the commercial internet by using the same free band, and the researchers cannot restrict it. So that is why we say that Wi-Fi network, we are using the Wi-Fi. This is called Wi-Fi. Whenever a wireless LAN is connected with a backbone network towards the internet, we say the Wi-Fi network with wireless fidelity. Huge amount of traffic through wireless network we are collecting. Okay, this is optical fiber connection, but at the front end we have the wireless LAN. Now, as I have started this class with the thing that we are in a transition phase, and what is happening apart from our daily life Wi-Fi applications, we are using the IoT applications, Internet of Things applications, by using the same band. By using the same band, we are applying our new applications based on the IoT devices. So considering this in mind, just see the Bluetooth. You see the Bluetooth uses the 2.4 up to 2.4 gigahertz. It also works with 5 gigahertz ISM band. Okay, another thing you should keep in mind that in 3 range the ISM bands are. One is around in 900 megahertz range. This is ISM band. One is in between 2.4 to 2.48. This is the global band that is unlicensed, and another is in between 5.25 up to maybe 5.75 gigahertz range. So these 3 are globally declared unlicensed band. Through these bands, we are actually using our Bluetooth technology, we are actually using our Wi-Fi technology and the IoT devices. Okay. Now let's see that this is the thing I have discussed in my last class, but still you see the devices, the sensors, the devices, these are equipped with one identity, that is the IP address. And for this, our IPv6 addresses are there, and we say that these devices are equipped with IPv6 address, and there is a protocol named 6LoWPAN. 6LoWPAN. Actually, WPAN, here you can see the term WPAN. WPAN means wireless personal area network, and 6 coming from IPv6, and low coming from low power personal area network with IPv6 addressing. This is called 6LoWPAN, and you see that what kind of devices we are using? We are using some sensors like ECG sensor, like temperature sensor, oxygen oximeter or oxygen sensors, motion sensors, uh, pressure sensors, heartbeat rate sensors. So different sensors, these are collecting my own personal body's information, and it also uses the same frequency band, that is the unlicensed band. So you see how much pressure and how much bottleneck is there at this band. So only for that reason I am discussing all the wireless concepts. Those are using the unlicensed band. And what these sensors are doing, they are sending the data through some application using our smartphones, and then thereupon using the Wi-Fi or using the mobile network. So here two networks are there. One is either Bluetooth, we can reach out our devices, and from the devices using the optical fiber, we can send that, using the broadband, we can access to the internet, or through the GPRS or 3G or 4G or upcoming 5G technologies, we can send our data towards the internet. So there are two ways, but of course, this is much expensive in compared to this one. Our Wi-Fi or typical broadband internet is much cheaper than that our mobile technologies. So keeping that in mind, I will start to discuss. And okay, another thing is that you see that the data rate expectation, or the required data rate, you can say, for these devices is very less, only 250 kbps, whereas the Wi-Fi devices can be with can work with 600 mbps. However, our upcoming Wi-Fi 6, we say, our upcoming Wi-Fi 6, the standard name is IEEE 802.11ax standard. This is targeting to achieve 1 Gbps of data rate by using our Wi-Fi devices. Okay, this is expecting that they can achieve 1 Gbps. But the earlier versions, what we have the earlier versions starting with IEEE 802.11, then A, then B, then G, then N, and then AC. And now in Bangladesh, now AC standard Wi-Fi access points are available, and through this maximum we can achieve 600 Mbps up to. But in general, before that we have the 54 Mbps data rate. So you see, it is in the megabit range, whereas the IoT devices have a very less demand of the data rate. Why? I'm coming to that point. Why this is high? This is high as because this Wi-Fi is no longer used for the ISM purpose. This is used for the commercial internet purpose. And you know, through commercial internet, we are exchanging all sorts of internet traffic. So that is why our data rate demands is very high. Now I'll talk about the today's lecture. As our course has one part, you see that is the embedded system. So I thought that this year I should talk about this embedded IoT network. Actually, in the previous year, I didn't give this lecture to the earlier year students, but this year I thought that I have studied. I'm working with this actually, so that is why I thought that I should discuss this thing with you. At least you will have a good knowledge on the recent work. Okay, so today I will talk about the embedded IoT network, and particularly one protocol, that is the LoRa wide area network, long range wide area network. One stands for wide area network, you know, and LoRa stands for long range. This IoT network is equipped with embedded devices, so that is why we say embedded IoT network. I have prepared this lecture based on one technical report, technical overview on LoRa and LoRa-1, developed by LoRa Alliance. They have started working from 2015, and it is the most recent protocol. And still, if anyone has any interest to work with this topic, you can go through by studying this. Okay, so first of all, what is LoRa? LoRa specifically emphasizes on the physical layer activities of the OSI model. You know that physical layer, data link layer, network layer, transport layer, and application layer, starting from the bottom to top, based on the TCP model. And LoRa specifically concentrated on physical layer, particularly I should say on the modulation technique. And through modulation, LoRa has ensured long range communication link. So one modulation technique they are applying, that is called chip spread spectrum modulation, which is an enhancement of the frequency shift keying modulation technique. And earlier, what is chip spread spectrum? You may heard about the two terms. One is frequency hopping spread spectrum. Another is direct sequence spread spectrum. Both of these technique is called bandwidth utilization technique. Both of them are bandwidth utilization technique, and the third version is the CSSS, chip spread spectrum technique. Logically, the bandwidth is utilized or bandwidth is spreaded over so that data security, data privacy, as well as bandwidth utilization can be ensured. Okay, so what chip spread spectrum ensures? It adds some encryption code with the data. Encryption code is added with the data, and for each bit it maintains some time slot. So with a particular time slot and with a particular synchronization approach, with each of the bit, one encryption code is added. So in short, if I discuss about chip spread spectrum, this is a summarized way to explain it. That for each of the bit data, the bit is encrypted through some encrypted code, and for encryption we have to maintain a synchronized time slot. Okay, and chip spread spectrum has been used in military and space communication for the decades due to long range communication distance that can be achieved and robustness to interference. Okay, LoRa is the first low cost implementation for commercial use. So for giving the idea of LoRa, I'm discussing these matters using one network architecture. So this is the LoRa long range wide area network architecture, where you can see at the one end we have the end nodes, and in the other end we have the application servers. Okay, in between we have the backbone networks. Now LoRa protocol particularly work in this range. You see the end nodes. What are the end nodes? The end nodes, these are typically the IoT devices. These are our IoT devices. Likewise, you see pay tracking. So pay tracking means that we are applying some neck belt. We are applying some belt into the neck, and that belt uses some IoT device, or let's say one GPS tracker is installed there, and we can track the pet. Wherever it goes, we can track the pet. Next, smoke alarm for fire detection system. We can deploy many devices, many IoT devices throughout one office area or throughout one area. And from there, if any smoke is detected, we can detect the area, and we can take earlier action against the smoke or against the fire. Water meter, trash container. This is very important because nowadays many students are working with smart environment technology or smart waste management technology. So the smart waste management technology, what they are applying that smart bins. So smart bins means automatically whenever it fills up 50% of with trash, so automatically one message will be generated and that will reach to the municipality or to the city corporation guy who is the collector of this trash. So that it doesn't overflow due to the lack of connectivity or due to the infrequent collection of the trash. So this is this trash container might have one IoT component. Vending machines, our ATM machines, gas monitoring system. Even nowadays we are using IP camera at our homes, and we can access the IP camera anywhere from any place. Though there is some controversy regarding the IP camera, regarding my privacy, my data is stored into the cloud that is available to the cloud providers or cloud service providers or the IP camera owners, manufacturers. So there is some controversy, but I am talking about the applications. So several applications I am showing you here, those are actually the IoT applications. And those, believe me, that those requires very less amount of data rate. And another thing is that those devices are connected with the gateway. This gateway is kind of the base stations throughout the rural and urban area. Now, the main advantage of LoRaWAN is that if this gateway placed in urban area, typically the distance of range is in urban area, typically it is around 15 kilometers. So this is from the IoT device up to this distance. This distance typically 15 kilometers. And in the rural area, it is around 45 kilometers. So you see that in an urban area, why it is less? Because due to the obstacle, due to the buildings, due to the so many interference, so many networks are available, so many frequencies are used for by the let's say by the microwave frequencies are used by the satellite, by the radio transceivers or the mobile operators. So that is why due to the interference, due to the obstacles, the range is less, but still 15 kilometers. But for the rural area, it is around 45 kilometers. Whereas the cellular technology nowadays we are using, the cellular technology that is around, say, let's say if we are having one base station in any area, that might cover a maximum omnidirectional range of around 5 kilometers, not more than that. So under this base station, around omnidirectionally around 5 kilometers are covered by the base station. And most importantly, it is very energy hungry. Energy hungry means more power consumption is required for this cellular technology, whereas LoRa doesn't need that much amount of energy. Okay, another thing is that this is the one end talk. Then after the data gathering into the gateway, what is happening? The data is sent through some backhaul network or the broadband Ethernet or the 3G, 4G or 5G network. This data is traveled through one network server up to the application server. Application server means I'm talking about the municipality or city corporation people. I'm talking about the fire brigade system or the fire track people. Then water meter, pay tracking, vending machines for the food suppliers, ATM machines for the bank providers. So these application servers belongs to them. Okay. Another important feature is that as we are going to have sufficient amounts of gateway, IoT gateway, so there will be redundancy of data transfer. So you see there are two ways of data transfer from each of the IoT end nodes. So data reliability or data transfer assurance is ensured in LoRaWAN. So as a whole, if I say that where actually LoRa protocol is applied in this range from the IoT device up to the gateway. But in the inside of the network, the typical TCP/IP with secure socket layer can be used. But of course, this is an equipment feasible to work with LoRaWAN. So that is why we say that a combination of these equipment can deal with both TCP/IP as well as LoRa protocol. So two protocol can be used in these devices. Okay, so this is as a whole the basic idea of LoRa, and what is LoRa I have talked about, and the advantage of LoRa is the long range capability, and we have single gateway base station can cover entire cities or hundreds of square kilometers. So already I have talked about that 45 square kilometer in the rural area. Okay. So these are the talks I've already mentioned. Let's have some other features. Where does LoRa low power wireless wide area network can fit? One technology cannot serve all the projected applications or volumes for IoT, but if you compare with Wi-Fi or Bluetooth, so Wi-Fi and Bluetooth, so that is why I have discussed the Wi-Fi technology and Bluetooth technology in my previous lecture. Those are widely adopted standard and serve the applications, but the problem is the power consumption issue, and also the cellular technology. This has a huge power resource, power requirements actually. But LoRaWAN or low power wide area network offers multi-year battery lifetime, typically 8 to 10 years. And with a small data rate demand or data transfer rate demand. As because why the data transfer rate will be less, the thing is written here that applications that need to send small amounts of data over long distances a few times per hour from a varying environments. For example, typically the smoke alarm sends the temperature. So we don't need to sense the each and every second's temperature to the server. Rather, every hour temperature data can be sent. So in 24 hours, maximum 24 data packets can be sent. So you see the data rate is very, very less in LoRa or in the IoT network. So where does the WLAN fit? The thing is, I have talked about typical LAN, that is the wireless LAN, low power wide area network that uses the LoRa protocol, and the wireless LAN uses the Wi-Fi, Bluetooth or Zigbee protocol. So these are the names of different protocols of wireless technologies. And the cellular network, this uses that GSM, 4G or 3G plus or HSPA or UINTS. Solely the utilization is around 45% for this. This is higher utilization in compared to the LAN, and of course the difference you see in terms of battery utilization we are talking, and the from the application point of view, it ensures high data rate. Okay, next. So the factors of low power LAN, for most critical factors is the network architecture. Already I have shown you the network architecture, the communication range, the battery lifetime or low power, robustness to interference, network capacity, network security. That is the thing I've talked during the in the first slide, that using the modulation technique it uses the cheap spread spectrum technique using some encrypted code, so data security is much more higher. Bidirectional data communication, one-way or two-way communication is possible, and variety of applications served. So variety of applications served, you can see the logos, that green network, green environment, medical, transportation, smart industry, smart building, smart grid or smart power system, smart environment or environmental effects can be monitored. Everything is possible through the Internet of Things, and the core protocol is the LoRa. Okay, now LoRa device class, I have maximum 2 or 3 slides more, then I will finish the class. And the LoRa devices are categorized into 3 categories, A, B, and C. Among them, the battery lifetime is much higher for the A category devices. These are the most energy efficient devices, battery powered sensors. And the class C has the less battery lifetime, but you see that for class A, the data communication latency is very high, because the class A is typically these are the end devices. These end devices are the class A, but some of the devices lies in between class B and C. These are also battery powered actuators are used. These are also energy efficient, but less latency is there for these devices. And the more nearer devices to the urban area, to the gateway, can be available with more power supply. But the devices, those are in the hostile environment or in a hazardous environment, we cannot supply the power to them. So that is why these devices should be more mostly depends on the battery powered sensors for collecting the data. Okay, next I will show you some summary. You see that LoRa frequency, which frequency we are using. You see, no country is even using it in the gigahertz range. I've talked with 300 kilohertz up to 300 gigahertz, and though the ISM frequency is in the 2.4 gigahertz and in the 5 gigahertz, but there is another ISM frequency in between 902 up to 928 megahertz. In between these frequencies are, we say, unlicensed frequency. And every country, Europe, North America, China, Korea, Japan, in India, is also using these frequencies for applying the LoRa. It demands very less bandwidth. Only particular points I will talk about: less bandwidth in the kilohertz range, and with a data rate of only 250 bit per second or 50 kbps, or 980 bit per second or 22 kbps. And still China, Korea, Japan, and India, those are working with their task group in definition by technical committee. They have not decided about their data rate and other factors. But in Europe and North America, the LoRa has started working with testing. Now, you may ask that why we are using LoRa, why not some other, what technologies else are there? Yes, of course, we have some other protocols. So why I am emphasizing on LoRa? Actually, you see the LoRa one is this one, spread spectrum, cheap spread spectrum. And the others use OFDMA, orthogonal frequency division multiplexing. Okay. These technologies are dependent on the cellular technologies. Basically, you see the LTE devices are there, long-term evolutions devices are there. These all are basically based on cellular. Narrowband IoT is applied in Bangladesh as well. Narrowband IoT applied by Grameenphone Bangladesh in the coastal area of Bangladesh, of Cox's Bazar, to track the deep sea fishermen, those guys who went to sea for collecting fishes. to communicate with them, the narrowband IoT devices is applied, but it is expensive. And you see basically the battery lifetime. I will point out few points that the LoRa ensures the highest battery lifetime among those. It's 90 months, but others is only 80 months, and these are not yet decided. This is one thing, and the data rate is quite good in terms of demand. And the main advantage of cheap space spectrum, it ensures the data security. Next, finally, this is a very smart picture that talks about the technologies today I'm talking about. I've talked about Wi-Fi, Bluetooth, LoRa, and cellular. And you see that Wi-Fi demands high power consumption. Cellular, of course, demands high power consumption. And Bluetooth demands low power consumption. LoRa as well as demands low power consumption. But in terms of range, Wi-Fi and Bluetooth has less range. Cellular has high range, but LoRa has long range. Cellular has long range as well. But in considering the power and range, LoRa is the best one for the IoT technologies, for the upcoming IoT technologies. So from this, we can conclude that. And finally, the advantages, the long range is the main advantage of LoRa, greater than cellular, deep indoor coverage. It works with a star topology, and it is a star topology, you know, right? This is a star topology. Everyone is connected with the same hub. Then low power optimization, the battery lifetime, they are targeting in between 10 to 20 years for the IoT devices. This is very important, and in compared to cellular, this is 10 times higher. Multi-uses, high capacity, multiple users can use, multiple tenants are there. That means multiple people can use those as those are publicly available, because the applications I'm talking about, most of them are based on the public interest. And of course, they are low cost. We need minimum infrastructure, low cost a node, because those devices are very lightweight and very less expensive. And open source softwares are there, because many people are working with the IoT applications. They are developing their own apps to interconnect the hardwares. So that's it. This is the final lecture today I have completed. I hope that these lectures make some also it will make some research interest, as because some of the students have communicated with me that on which topic you can work with in future. So you can think over Internet of Things, Internet of Things, this topic, while specifically you can consider this in your mind, that what technologies we are having nowadays, the narrowband IoT and LoRa IoT. So based on that, you can carry on your next day's research as well. So that's it from my side. Any question?
স্যার লোরা তো মনে হচ্ছে বেশ ভালো টেকনোলজি। তো স্যার এটার কি কোনো ডিসঅ্যাডভান্টেজ নাই, মানে কি স্যার ডাটা রেট থেকেই শুধু?
Of course there's some main disadvantage is the low rate, but depending on the application, depending on the application demand, this is the best one. So why do we need, আমি যদি narrowband IoT ব্যবহার করি, I have to spend a lot. I have to spend a lot in the infrastructure, in the technology, and I'll not gain that much in terms of battery lifetime. মানে energy একটা issue, communication infrastructure is an issue, and communication protocol complexity, operational complexity is another issue. So এগুলোকে চিন্তা করে so far this is the best one.
Yes, sir.
Okay, but advancement is going on, মানে এগুলোকে এখনো মাথায় রেখে পড়াশোনা করা হচ্ছে বা রিসার্চ চলছে। সব এগুলোকে এক একটা টাস্ক ফোর্স কাজ করতেছে। তো সবাইকে বিট করার জন্য কিন্তু কাজ করতেছে। Who knows? Because yes, তুমি যদি মডুলেশনের পার্সপেক্টিভে বলি, OFDM is the best one. OFDM is the best one. বাট ওয়েবডিএম যেখানে ব্যবহার করব সেখানে তো আমি কম এনার্জি এনশিওর করতে পারবো না, ইউ সি। সো দ্যাট ইজ ওয়াই দেখো 18 মান্থস, এবং এরা তো ডিফাইন করতে পারিনি, ঠিক আছে। যেখানে ওয়েবডিএম নিয়ে কাজ করব বাট আমি এনার্জি কনজাম্পশন কমায় ফেলবো, এটা আমি ক্লেম করতেই পারি না। ওকে, এবং ব্যান্ডউইথ রিকোয়ারমেন্ট ইন দ্য মেগাহার্জ রেঞ্জ, এদের ওয়্যারএস এদের ব্যান্ডউইথ রিকোয়ারমেন্ট ইজ দ্য কিলোহার্জ রেঞ্জ, মানে অল্প ব্যান্ডউইথেও কিন্তু আমি বেশি ডেটা পাঠাতে পারবো, আমার ব্যান্ডউইথ হাঙ্গরি না আমাদের অ্যাপ্লিকেশন গুলো। এরকম কিছু ফ্যাক্টর গুলো থেকেই যাচ্ছে আর কি।
জি স্যার।
ওকে, এনি আদার?
স্যার ওই
Okay.
ল্যাব কুইজ যেটা হবে আর কি এমসিকিউ, ওটার জন্য কি কি পড়বো এটা একটু যদি স্যার।
আমার যে ল্যাব শিট গুলো আছে এবং যে ল্যাবে যে আমি কাজগুলো দেখিয়েছি তোমাদের প্রোটিয়াসে,
জি স্যার।
এই জিনিসগুলো একটু মাথায় নিবা, শেষ।
ওকে স্যার, থ্যাংক ইউ স্যার।
ঠিক আছে, এগুলো থেকে হয়তো একটু ট্রু ফলস আমি হয়তো 15-20 মার্কের কোশ্চেন করবো আর কি, হয়তো 5টা ট্রু ফলস, 5টা এমসিকিউ, আর 5টা একদম 3-4 লাইনের শর্ট, 3-4 ওয়ার্ডের শর্ট আনসার। ওকে, এবং গুগল ফর্মে ছেড়ে দেবো, তোমরা খালি জমা দিবে, হয়তো 15-20 মিনিটের একটা কুইজ নেব, মানে মার্কস যত থাকবে তত মিনিটের কুইজ। ওকে, okay, so that's it from my side. Thank you, and I'm waiting for your response on the next week. Next week there will be no class, but I like to utilize the Tuesday and Friday as well as Thursday class based on your suggestion. So thank you.